Hi guys, my name is Trevor Favrot, and then I am the group leader for the ranking cycle experiment for next week. So basically outline what I'm going to talk about. I'm going to talk about the background theory, some governing equations, the procedure that we're going to have to use for the ranking cycle, some predictions, and then we'll have time for questions. So first, I wanted to talk about the actual background of the ranking cycle. It produces electrical energy for 4 stages. First is the pump right here. That increases the pressure from points 1 to 2. That increased pressure, the fluid goes through the steam generator or the boiler, which increases the temperature and makes it into a vapor. It makes the water into a vapor, so it can go through the turbine from points 3 to 4. The turbine does the work and can produce electrical energy from the vaporized liquid. And then from points 4 to 1, it goes through the condenser, where it condenses back down to liquid form, so it can be pumped through to the pump and back into the cycle again. So as you can see, it's a cyclic process, and you need all these parts in order to complete the cycle. All right. So to continue, on a PV diagram from points 1 to 2, which is from the pump going into the boiler, it increases the pressure from points 1 to 2, and then from 2 to 3, it stays at constant pressure, and it actually increases the temperature. And then from 3 to 4, it's a decreasing pressure after the work is being done on the liquid, on the turbine. And then from 4 to 1, it stays at constant pressure again when it goes through the condenser back to fluid form. And then on the TS diagram, we assume that from points 1 to 2, it's isotropic. There's no change in entropy, and it just increases the temperature from here to here, and it goes from one constant pressure line to another constant pressure line. So from points 2 to 3, there's an increase in temperature through the boiler, and like I said before, from 3 to 4, it's isotropic, so there's no change in entropy when it goes through the turbine, and then from 4 to 1, it stays at constant pressure. All right, some governing equations that are going to be used, mostly for the group reporter. All these are important. You know, the pump work in, the condenser, the turbine work, the turbine efficiency, and the overall cycle efficiency. And for the cycle efficiency, you can use the enthalpy values to determine the actual overall cycle efficiency. So the procedure, we're going to have a pre-startup to make sure everything's cleaned up and we drain all the water out of the boiler and everything before we add new water in. And then the system startup, we're going to be basically making sure everything starts up correctly. We're going to steadily increase the pressure into the boiler so we can get it working properly. And to ensure that we get good readings, the system startup has to go exactly as planned. And then the shutdown to make sure everything's off and everything is cleaned up at the station. So some sample calculations. We can do the work of the pump and then the turbine work here from the equations, the governing equations here. And then you can go get it in BTU per pound of mass from points 1 to 4, 1 to 2, 2 to 3, it's 4 to 3. And I got the overall cycle efficiency of 15%, which was close to the overall cycle efficiency of the last presentation that we saw. And you can use these equations here, and like I said before, you can use the enthalpy values to find the overall cycle efficiency, and the heat in and pump work in, and then you're going to get it in BTU per pound mass. So that's the overall cycle right there. Are there any questions?
I have a question that for the procedure, like what is the factor that you do in the experiment to maintain the stability?
You have to keep the boiler at a certain pressure. I believe it's from it's 110. pascals. Around that. And you have to keep it at that pressure the entire time to ensure right measurements are taken and everything's okay.
Actually, part of the manual says that, but during the experiment, we generally keep the voltage
Oh,
constant.
10 volts.
Yeah, 9.
That's